All right, hello everyone. Today we're going to look at rotations about the origin. So a rotation on the coordinate plane will move points about a fixed point called the center of rotation. For today, the center of rotation is going to be the origin on all of the examples. So rotations are expressed in terms of angles, degrees, and can be clockwise or counterclockwise. Let's scroll down. And let's go over a few things quickly. So I'm focusing right now on this grid right here. So just to give you an idea on what 90 degrees, 180 degrees, and 270 degrees look like, because I know that for most people it's been a while since you've seen something like that. So if we start here, call this 0 degrees. We move up here, this is 90 degrees. Move here, this is 180 degrees. Again, thinking about this as our starting position. And this right here is 270 degrees. And if you come back to where you started, that is 360 degrees. Just to give you an idea on what 90, 180, and 270 degrees look like. And do not forget, this direction is counterclockwise, which is in math the positive direction. And then going this way, of course, would then be clockwise. Okay, so let's graph the point P. Point P is 2, 5, which is up here. So this is point P. And as of right now in the course, we do not have the most sufficient tools to kind of really prove this or go through this in a formal way. So I'm going to go through this, and it's going to be slightly informal, mathematically that's speaking, but it'll get the point across. So our center of rotation is right here at the origin, the red dot I just drew. And if we connect, okay, let's connect a line from here to here. It's a little wobbly. Let me fix that a bit. Okay, so this is a line connecting from the center of rotation to the point we are actually rotating. If we want to rotate this point 90 degrees, we need to make a 90-degree angle between this line connecting our center of rotation to our point. We need the line that connects the center of rotation to our transformed point. We need those two lines to be perpendicular or have 90 degrees between them. Again, 90 degrees is the L shape if you're looking at this coordinate plane. So we need to find a way to create another line in which the angle between that line and this line are 90 degrees. And if we go over and look also at our change of y and change of x, we have this right here. Our change of x, or delta x, is here. Change of y is here. So this change of x is 2. This change of y is 5. Rotating 90 degrees, again, 90 degrees, or perpendicular lines. If you remember anything about perpendicular lines, you'll remember something about their slope, which is that their slope must be reciprocals of one another, meaning it must be, if it's a fraction, that fraction must be inverted and the sign changed to negative. That is all a very fancy way of saying, hey, let's go, instead of 2 across, go 5 across to the left and 2 up. Right here. This is point P prime, rotated 90 degrees. So I think people can see here how this was now 5, and this is 2. So this line connecting the origin to our P prime, this angle between these two guys is 90 degrees. Okay? hopefully that wasn't too confusing. And let me erase this really quickly. So, using the fact on what you probably don't recall, but from Algebra 1, you remember learning some perpendicular lines, maybe from middle school math as well. Perpendicular lines will have 90 degrees between them, and their slopes will be reciprocals of one another. So we have successfully rotated this 90 degrees. So our new coordinate, though, it turns out, is -5, 2. Okay, so if we look at this relationship from 2, 5 to -5, 2, and we put it in a general sense, so in terms of x and y, our xy went to -y, x. So this is our general rule now for 90 degrees, and this is the fact we're going to use to go through 180 and 270. 180 degrees counterclockwise or clockwise, it's the same thing. Instead of trying to create 180 degrees from point P to P prime prime or P double prime, let's just do another 90-degree rotation from P prime. Because if we do another 90-degree rotation, which we already have a rule for, right? Well, a 90-degree rotation counterclockwise to another 90-degree rotation counterclockwise is clearly 180 degrees counterclockwise. So let's rotate P prime 90 degrees. So our rule, again, is -y, x. P prime is -5, 2. So now this changes to -2, -5. Okay, let's graph that, -2, -5, which is right down here. If we connect those, it is in fact 180 degrees, or a straight angle. This is 180 degrees. And now, let's look at this point. This point is -2, this is P prime prime, -2, -5. So again, starting from P though, let's find a rule on how we go from 2, 5 to -2, -5. So essentially, we go from xy to -x, -y. Awesome. Now, if we go again to get 270 degrees, P triple prime, what we're looking for. So we can just do another 90-degree rotation since we know that rule. We can do that to P double prime. So doing that to P double prime, using the 90-degree rotation rule, we go from xy to -y, x. So we go to +5, -2. So 5, -2 is right here. This is P triple prime. Boom. So this is 90 degrees. This is 90 degrees. This is 90 degrees. And this is 90 degrees. So again, to come up with the rule from our original point, 2, 5, and then we end up with 5, -2, well, this means we go from xy to y, -x. So to summarize, for a 90-degree rotation counterclockwise, which is the equivalence of 270 degrees clockwise, we go from xy to -y, x. And from 180, we get -x, -y. And 270 degrees counterclockwise, we end up with y, -x. So these are our rules. Again, the way we derived them might not be the most formal way, but for the purposes of the class, I think it's sufficient. So let's go to an example. I will look at example 3. So it wants us to rotate the coordinates of this triangle 180 degrees about the origin. Okay, well, point T is 2, 5. our rule for 180-degree rotations is we go from xy to negative x comma negative y. Therefore, since on t we have 2, 5, after you rotate that 180 degrees, t prime will be negative 2 comma negative 5, which is right here. This is t prime. Point R is 4 comma 5. So again, rotating 180 degrees about the origin, we go from xy to negative x comma negative y, so negative 4 comma negative 5. So here we have R prime. Now, for I, we have 4 comma 3. So this goes to negative 4 comma negative 3. I prime. Okay, draw your triangle. And we are done. Again, these are new points. You just change them all from x comma y to negative x comma negative y. And that is it. So I recommend trying example 2 on your own, but that is it. Thank you guys.